and I work in the Communication and Theater Department, Liberal Arts Division on South Campus. I use problem solving with my students when teaching them about the technical theater production process, and specifically the roles of theatrical designers and the production manager in professional theater. These models demonstrate to students how to be flexible and adaptable to changing conditions in the workplace. This slide features the visual representation of a structured problem-solving model that guides students and teams through the process of solving problems. This model is iterative and flexible. It loops at the reflecting stage, but overall, it promotes a thoughtful and collaborative approach to solving problems. It's not always a linear process, and multiple steps might even be repeated before the problem is solved.
This is how we use problem solving in the air conditioning trade, and we teach students how to problem solve. We always start with teaching students the sequence of operation. If you don't know how something should operate, you won't be able to troubleshoot and resolve any issues. So once the student understands the sequence of operation, they're going to assess the system and they're going to determine the probable causes of the system. We try to break this down into three categories. Is this a mechanical problem? Is it an electrical problem? Or is it a design problem? Once we determine if it's mechanical, electrical, or design, let's say this is an electrical problem, then we use a sequence of operation of how the system should operate correctly electrically, what could be causing what we're seeing here that differs from a normal operation, what test instruments do we need to troubleshoot to find out where our problem is. So that's where we're going to take our corrective action. We're going to get our test instruments, our amp meters, our voltmeters, our meters that read resistance, and we are going to troubleshoot that circuit. Once we troubleshoot the circuit, then we are going to determine where we think the fault lies based on the information that our test instruments give us. We're going to take the corrective action, replace that component. Then we are going to start the system again, and we're going to verify that now the system is working correctly. Once we verify the system's working correctly, we go all the way back to the beginning. Just because the system starts and is operating, don't mean it's operating correctly. So we assess the entire system. Is everything mechanically working? Is everything electrically working? And is it doing its job either to heat or cool the structure? Once we know the system's working properly, based on the sequence of operation of that piece of equipment, then we will report to the customer that the system is now up and running and their issue has been resolved. That's how we use the problem solving to teach our students in the air conditioning trade.
Hi, my name is Nicole Gant, and I work in the First Year Academy Liberal Arts Division on South Campus. Teaching the ACA course, I work with a lot of first-time, first-semester college students, and one way that I use the problem-solving process is to help them navigate and solve issues which may arise. I also use it as an opportunity to share about Wake Tech resources and encourage students to utilize them. One such example, I have a student who comes to me and says, Miss Gant, I can't submit my homework to Blackboard because the Wi-Fi at my house isn't working. Okay, I can understand that. So I would then ask the student, do you have time after class today? Usually they say yes, and I encourage them to use the computers in the library or the Open Computer Lab on campus, where they would have access to Blackboard and be able to get their work submitted. This model is used to help students create a note-taking plan and applied to many other subjects in the ACA course. What elements of problem solving do you see in this model? In this model, blocks 1 and 2 are equivalent to the define step, block 3 is learn, and block 4 is brainstorm. Block 5, asking which choices will I commit to doing, maps to try it out, and block 6, the students evaluate. We notice that in this model, some steps are not used. This model doesn't show step 4, plan, though we might see it in block 5. Neither does it include step 7, reflect and revise, or step 8, share. What is one way that we could include one of these?
Hi, I'm Adrienne Lineback, and I teach geology in the Physical Sciences Department in the Math and Sciences Division on RTP campus. I use problem solving in all my labs when I'm teaching. I also use it in just a general process when students ask me questions. They know they're going to be asked to define exactly what it is they're trying to get the answer to, and to see if they can tell me what information they need to be able to answer that question. Here in this last mapping example, we are going to map the scientific method as it applies to our problem-solving process. As we can see as we move through in mapping, observe and define, we question and research goes along with learn and brainstorm, hypothesize, plan, experiment and try it, test hypothesis, evaluate it, draw conclusions or reflect on it, and finally report it. As you can see in this slide, the scientific method is already pretty close to the problem-solving 8 steps, while showing the emphasis on communication through our focus on the define, reflect, and share steps. A report is not the only way to share the results of the problem-solving process. Keep this scientific method example in mind as we move on to the next section.
Now that you have some examples, we'll take a few minutes to try and map out a process that is specific to your discipline. It's your turn. In the PS200 course shell, go to the PS200 Discussion Forum 1. Hopefully, the process of working through the mapping for your discipline or a specific sample scenario will help you grow more confident in the process and allow us to find any areas where we need to develop our understanding of the process better. Also, posting these will help us see more samples from different disciplines. There's samples there of the mapping diagram that you can work with. Please remember to respond to a peer. The prompt is in the discussion forum.
Hi, I'm Jacqueline Popp from Sociology. I work on South Campus and online. I'm the assessment lead on Solve It, Save It, QEP, as well as EPIC in the past. And so now you've completed part 1 of this PS200 course standards training. Once you've completed your mapping activity, it's time for your first knowledge check in Blackboard. You can retake this assessment as needed, and you need to earn an 80% on all 3 knowledge checks to pass the class. Please take a few minutes to complete knowledge check 1 before proceeding to the next portion of the training. Also, as the assessment lead, I just want to say thank you for your participation in all the various assessments for Solve It, Save It, QEP.